Hello friends, in today's class I'm going to talk about the basic concepts of the trigonometry, and my lecture will be divided into three different parts. First one is the right angle triangle, and the second part I will talk about Pythagorean theorem, Pythagorean theorem. Okay, and in the third part I will talk about the angles and how to find unknown angles and sides in a right angle triangle. So let's begin our lecture with a right angle triangle. As I said, the first part is right angle triangle, so I'm going to draw a right angle triangle over here. A right angle triangle always has a 90-degree angle. One of the angles will be 90 degree. In this case, in this triangle, this angle which I have showed over here, this is 90 degrees, and that's why it is called as right angle triangle. Let's suppose now this angle over here is theta, and another thing which I want to talk about is the sides. So the side opposite to the right angle triangle is always called as hypotenuse. Okay, and the side opposite to the angle theta will be called as opposite side, and the side adjacent to this angle theta will be called as adjacent side. Notice this thing is really important to understand, because if, let's say, if I change this angle theta over here, now this top angle is angle theta. Now the side opposite to this will become opposite side. It's not always that the vertical side will be the opposite side. Okay, it is the side opposite to the given angle. So this is opposite side, side adjacent to this one is adjacent side, and the longest side, which is always opposite to the 90 degrees angle, will be called as hypotenuse side. And the hypotenuse, as I said, it is the longest side out of all the three sides. Now, as we said earlier, that we're going to talk about the Pythagorean theorem. So Pythagorean theorem says that hypotenuse square is equal to opposite square plus adjacent square. I'm gonna draw a triangle one more time over here. Let's say this is my triangle, and this side given to me is 3 and this side given to me is 4 meters, 3 meters. I want to find the hypotenuse. How can I find the hypotenuse? So hypotenuse square will be equal to 3 square. Okay, let's say this angle is theta. So 3 square plus 4 square, and notice when this hypotenuse, when this square will move to the other side, it will convert it into under the root. So when this from this square from the hypotenuse goes to the other side, it converts to under the root. Now under root of 3 square is 9 plus 4 square is 16, and the value will come out to be 25, and I can write it as 5 meters. Alright, and let's take another example. Let's take an example over here. Again, a right angle triangle is given to me. let's say this side is given to me again as 3 meters and this side given to me is 5 meters. I wanted to find this side. This angle is theta, so this is opposite and this is adjacent and this is hypotenuse. So let's apply the same Pythagoras theorem again. So the Pythagoras theorem says hypotenuse square equal to opposite square plus adjacent square. Alright, so opposite again given to me is 3 square plus adjacent, I'm going to suppose it as x square. Hypotenuse is 5 square. Okay, so 5 square, notice when the 3 will go on to the other side of the equation, the sign will change. So 3 square equal to x square. And the final value for x square will be, I'll write it down here. So the final value will be is 16 equal to x square and under root of 16 equal to x, which will come out to be x equals to 4. And we'll write down the units over here also. So that's how we can find the sides of a right angle triangle by applying the Pythagorean theorem. Now the third thing, which is really important, how to find the sides or the different angles in a right angle triangle. So one of the most important thing to understand is if one of the angle is given to me, let's say this theta angle, again this theta angle is 30 degrees, which is in this case now given to me that the value of theta is 30 degrees, and this hypotenuse is 5 meters, which is given to me. If I'm provided with an angle and one side, I can find rest of the sides and rest of the angles of a right angle triangle. How? Let's see. Because I know this angle is 90 degrees, so this angle is 30 degrees, this angle will become 60 degrees. How? So sum of angles of a triangle equal to 180 degrees. So 30 degrees plus, let's say this angle, I'm going to name it as alpha. 30 degree plus alpha plus 90 degrees equal to 180 degrees. So alpha value will come out to be 180 minus 90 minus 30 will give me 60 degrees. So that's how I can first of all find the angle. Now the most important part, one of the side, this 5 meters hypotenuse is given to me, and I wanted to find out the opposite side and adjacent side to angle theta. That's what I wanted to find out. So how can I find out? So there are 3 trigonometric ratios which we will use. One of those trigonometric ratio is sine theta. So sine theta is equal to opposite upon so sine theta is opposite upon hypotenuse. So this is opposite upon hypotenuse. And the second trigonometric ratio is cosine theta, which is adjacent upon hypotenuse. And the third one is tangent. Oops, sorry guys. So the third side is tangent theta. So if I want to write down tangent theta, which is equal to opposite upon adjacent. Alright, now let's apply first trigonometric ratio and try to find out the side. So sine theta, in this case theta value is 30 degrees, so sine of 30 degrees equal to opposite side to the angle 30 degree is unknown, so that's what I wanted to find out. Hypotenuse is given to me, which is 5 meters. So sine 30 degree is equal to 0.5. If you're going to put this value in your calculators, you're going to find 0.5. Notice this is in degrees, so your calculator should be in degrees to get the right answers. So 0.5 equal to opposite upon 5. So I'm going to multiply both sides by 5 and I'll cancel this 5. This will give me opposite side as 2.5. Alright, so this opposite side is 2.5 meters. Now I wanted to find the adjacent side. How can I find the adjacent side? So for that, I can use any one of the formulas. I can use this cosine formula also. Can use this cosine formula, or I can use the tangent formula. The result will be the same. So right now I'm going to use the cosine formula. So cosine theta equal to adjacent, which is in this case unknown, adjacent divided by 5. Hypotenuse side is 5. So cos of 30 degrees, I need to find the value of cos of 30 degrees. So give me a second guys. So cos 30 degrees is equal to cos 30 is equal to 0.866. So cos 30 is 0.866, and which is on this side adjacent divided by 5. So what I'm going to do, adjacent multiply by 5. This is divided by 5. 5 cancel. Multiply this side by 5 also. So the answer which I'm gonna get is by 5, 4.33. So the answer which I'm gonna get is 4.33 adjacent side. So I'm gonna draw it again over here. So this is a right angle triangle, and this angle over here was 30 degrees given to me. I was able to figure out this angle as 60 degrees, and and then this side is 5 meters given to me. So this side came out to be 2.5 meters, and this side came out to be 4.33 meters. Notice all these formulas, these trigonometric ratios, I can apply to right angle triangle, and Pythagorean theorem also I can only apply to the right angle triangle if the triangle shape is something like this, in which case this angle, none of the angle is a 90 degree. Okay, for a triangle to be a right angle triangle, one of the angles has to be at least 90 degrees. In this, there is no angle which is 90 degrees, so I cannot apply the Pythagorean theorem on to this one. I cannot apply sine, cosine and tangent ratios to this triangle also. So if the triangle is like this, can I apply these ratios to this? Can I apply the Pythagorean theorem to this? No, the answer is no. Okay, it has to be a right angle triangle. So one angle over here is 90 degrees. So thanks a lot. Hopefully you enjoyed the lecture. Bye now. See you soon.